kind of wondering if people are against me in the sense or against this theory, if not against me in a personal sense, because it sort of simplifies what they what they think is complicated, and I don't think they like that really, do they? I suppose I wouldn't, you know. I'm a normal person as well in a sense, right? And if I'd written this as extremely complicated, someone simplified it for me, I'd think, oh dear, well that's not it. You've misunderstood that. Okay, and I do get these kind of comments on my videos and my essays quite a lot, you see. People say, well, this is ridiculous. What about such and such a theory? What about relativity? You know, what about the speed of light? You haven't said the speed of light's 186,000 miles a second in a vacuum. You need to say that it's in a vacuum. You know, the speed of light can't be broken, or the speed of light can be broken, for example. I'm like, look, there's three things. You know, right? So I'm basically super simplifying quantum theory, all of physics, all of mathematics as well. And people don't like it because mathematics is taught as a complicated subject, okay? Now, if I said I'd done A-level maths, which I haven't, okay? Imagine I said I've done A-level maths, I'm studying mathematics at university, and I started reeling off some complicated equations or something, or some kind of words that you didn't understand, okay? You might think, cool, he knows what he's talking about, you know, cool. And the mathematics, the word mathematics or maths, it just triggers something in your head, doesn't it? Oh no, this is way beyond me type thing, okay? But it isn't, because it's only talking about one, singular, the opposite to one, non-singular, and neutral, repeating, and then you define patterns within it and everything else. And if you see it as a whole, all mathematics as a whole, then it looks extremely complicated. But the trick is you break things down into smaller pieces. So the sooner you can realise that there's three potentials within mathematics, the easier it becomes to study. The same goes with physics, the same goes with philosophy. There's chicken and the egg, for example. Which came first? I get a lot of people saying, well, according to this genetic theory, the egg must have come first because it creates the chicken and in such a way and all this. I'm like, well, this is a philosophical paradox, basically, and the answer is you can't prove one or the other answer, really. You could spend all your life arguing that the chicken came first, and then someone else could spend all their life arguing the egg came first, okay? And then you've just got the two opposites. But when you introduce neutral, you realise that it's about three potentials. Each one is equally possible. The chicken came first, the egg came first, neutral in the middle, okay? And this works for everything. As I say, I think it probably gets people's backs up in sort of in academia, if you like, maybe, that I'm super oversimplifying everything. I mean, literally everything, because this is a theory of everything, obviously. But this is, I don't know, the pride isn't a good enough reason to discount this theory, I don't think, okay? Now, when I first started writing this, I tried to write it in real, how do I put it, high-minded terms, you know. I tried to use all these big words and write it like a real, if we can postulate such and such, then we can understand so-and-so, subatomic particles and this and that reaction and stuff. And I thought, well, what's the point in me sort of pretending to be something I'm not really? You know, and trying to write in these complicated things which automatically sort of excludes a lot of the world's population who don't understand the words I'm using. I don't necessarily mean the English language words, I mean the specific physics words or definitions within mathematics, like such as the zeta function and things. If people hear that who aren't familiar with those terms, or even worse, see them as extremely complicated and high-minded terms that they can't possibly understand, then it puts them off, you see. But if I just say, well, look, within every single mathematics theory, no matter how complicated or how high up it seems or whatever, the Riemann hypothesis, which is my favourite problem of all time, okay, that is my number one favourite problem. And all I'm saying about the Riemann hypothesis is you've got a graph like this, and you've got a load of zeros going here in the middle, okay? Essentially speaking, that is what the Riemann hypothesis is. And Riemann's hypothesis was, do these zeros carry on in this line forever? Unchangingly, okay? Now think about it, unchangingly, okay? What is it? It's a singularity, okay? So, if things aren't going to change, that's fine, we can say, right, the Riemann hypothesis is true, as in, the Riemann hypothesis, won't change, the zeros won't move off the critical line, as it's called, okay? Now, because if I said this is the zeta function, the Riemann zeta function, and I gave you a load of numbers and a load of symbols and stuff, you'd be like, whoa. But if I just said, look, you've got a graph here, and you've got a graph here, and you've got like a neutral line, you've just got a line. You can draw it on a piece of paper. It's this, 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 like a triangle shape, sort of, okay? That's how simple it really is, without the words. The words complicate things, and I think people do tend to use them a lot as a matter of pride, really. They spend, I mean, I don't blame them, they spend years and years, like 20, 30 years maybe, studying mathematics and studying the terminology and studying the relationships between numbers and all the different patterns. And then, I mean, there's a certain amount of respect in you. Imagine the mathematician with the beard and the glasses and the, you know, the unkempt appearance and stuff, sitting in a dark office just reading numbers all day like Erdős did, The Man Who Loved Only Numbers, which is a book I read and really enjoyed. Anyway, but it's not necessarily that difficult to understand. It's just three potentials. If you don't want to understand or don't need to understand the details, okay? The details being all these words to describe such and such a pattern within maths and all this, but they all had to be invented somewhere along the line. Someone had to say, look, okay, well, I'm inventing the new word called equation, and this means this. I'm inventing algebra and calculus as well, which I've done another video about, okay? Like calculus is Latin for pebble, for example. This is how simple these things can really be, okay? So all calculus means is you've got a fluid moving along. For example, this is differential calculus in relation to Navier-Stokes equations. Okay, so you've got a fluid moving along, you drop a load of floating dots in it and measure the time difference between each dot as it passes by you. That is essentially, simply, what it means. If you read this in a mathematics book, I don't think even I'd understand it, to be honest. I really don't. If I read an actual book about the Navier-Stokes equations, going into all the details, you can't get a handle on it. But when I just say, oh, you just drop these points in and measure them, that is how simple it is. And the same works for every kind of knowledge that there is. It's only the details that complicate things, okay? There's three potentials creating everything, and that's about the be-all and end-all of it, essentially, okay? And I'm hoping with this video to stop you feeling so intimidated by things that you think you don't understand or think you can't understand, because all you have to do is find the simplicity within the complication and you're on your way.